The first speakers are Harry Paul. He's the Cybersecurity Advisor for Customer Service and Support at OSIsoft. And Will Price is an independent security researcher for Synergetics. They will be presenting Tying Bow Ties from PHA to the Cloud. Please welcome Harry and Will.
All right, thanks for joining us for Tying Bow Ties. Because suspense is overrated, we're just going to go ahead and tell you the 3 problems that we're trying to address with this topic. First of all, it can feel counterintuitive to look at the cyber threats posed to a power grid that we saw in Ukraine, and then juxtapose those next to the everyday threats that you can see from, for example. Okay, I got the mic now. So it can be counterintuitive to juxtapose these cyber and physical threats, but since ultimately we can reduce these to threats with defenses and impacts with reductions available, there's really no reason why we can't do that comparison. The second thing that we want to do is we want to visualize complex attacks. Often there is not a single channel used or a single mechanism used for an attack, so how do we look at these non-trivial attacks without getting bogged down in the combinatorics of all the different combinations we can run into? And then lastly, we want to look at a more complex look of security. So instead of taking just a view of the network diagram with the walls on fire, we want to look at the other factors in addition to passwords and firewalls. And at the crux of this, we feel that bow tie analysis is a technique that is well suited for this type of visualization and communication. And so bow tie methodology was really made into an industry standard for safety by Shell in the early 90s. And essentially we have a hazard, which is anything with the potential to cause harm. It could be high pressure steam in a pipe. It could be operating a web server on your network. It could be sipping a hot cup of coffee. And then you have a top event where you lose control over that hazard. And bow tie analysis allows us to enumerate the threats that could cause that top event, the defenses that we put in place as barriers. It shows the impacts and then the barriers we can put in place to reduce that impact should it occur. So I'm going to hand it over to Will to talk about an OT scenario.
All right. Thanks, Harry. First, I want to thank Dale and Harry and OSIsoft team to allow me to come and talk to you today. I think Dale nailed it when he talked about the theme for the year, come together. I know we can all relate to that. You know, we need each other to help us out in this space because we're dealing with very difficult problems when you talk about OT security and reliability and safety. Especially when you talk about, you look at the operations folks and bringing them together with the C-suites, as well as bringing together the plant managers, the VPs, and the subject matter experts. So it's pretty important that we come together and work to solve these complex problems. All right, so we'll get started off. I'm gonna just briefly touch on the process hazard analysis, or PHA. Basically what it is an assessment of an industrial process that's designed to improve safety and reduce the unwanted release of hazardous toxins or hazardous chemicals in the air. Here we have some other examples of analysis that's used in the oil and gas and chemical space. Hazard and operability study, HAZOPS, failure mode and effects mode, or effects analysis, layer of protection analysis, LOPA, and the fault tree analysis. One other analysis is used in that space in the chemical, oil and gas refinery space is what's called the fishbone, pretty much like a root cause analysis. All right. So for the OT scenario that we chose, we're targeting chemical refineries, oil and gas, and manufacturing plants. The equipment considerations are infrared cameras and sensors, and the impacts are the gases in the environment, you know, vapors and toxins in the air. Pretty serious things when you think about the nature of what goes on in these sites, these plants, and what they're dealing with. Future opportunities, we're going to be focusing on the bow ties and how to bridge the gaps between a PHA and the critical cybersecurity controls within the OT operating environments. So bow ties play a pretty significant role as a tool that we can use to help us out in analyzing and assessing what we have to consider on top of your traditional safety and regulatory things that you have to deal with. So our target within the OT environment, we decided to focus on what's called the Fluid Catalytic Cracking Unit. Basically, with the FC, I reference it as the FCC, and it's basically designed to convert low-value, thick oil into high-value gasoline by cracking the large molecules apart into small molecules. So you're basically talking about the whole process in an oil and gas refinery. You have the thick oil, and it goes through the process, and it comes out to something usable and sellable to the world. You think about the gas in your cars, airplanes, the travel, boats, ships, you name it. And in addition to that, this diagram here depicts the critical items that are involved. You have your regenerator, reactor, and fractionator. Those are the core components of the FCC. And for our scenario, in terms of what we need to consider, we chose to research and find an actual incident where the FCC unit experienced vibrations, and that ultimately led to the ESP, or electrostatic precipitator, to explode within an actual oil and gas refinery. Pretty serious stuff. Fortunately, only 2 people were injured, and they were able to get a control around the processes that they were dealing with, and so it's pretty significant. In addition to that, when you look at the actual impact to this particular incident, it could have been a lot worse, right? So within the proximity of the refinery, you have the public receptors around that area that span around a 3-mile radius. And within that 3-mile radius, they did the analysis and found that there were 330,000 residents in that area, 71 schools, and 8 hospitals. So imagine what could have happened if the tank, let's say, got hit from the debris from that explosion of the ESP. It could have been very, very catastrophic when you talk about the hydrofluoric acids that could have been released in the air. All right. So did some research on another oil and gas company that provided some great stats from an impact perspective. They did an assessment on 500, the last 500 oil and gas and chemical incidents. So if you look at the cyber impact to that, it's pretty significant. You can relate this from your traditional PHA analysis into what actually goes on into even the public, the private energy sector, right, with the power utilities. So what they found was there were inadequate management and use of engineering information that was the root cause or contributing factor to 15% of the last 500 incidents. So we're talking around 75 incidents. That's pretty significant in terms of using the engineering information that's available to help, mitigate the risks within the environment. When you talk about releases of gases in the air and toxins. The cost, $180 million per year. Now I know with the fluctuation of gas prices, some say, well, that's not a lot of money, but if you think about how the prices have been fluctuating the last couple of years, that is significant. So we found some additional links and research in terms of, with all these incidents that have occurred, the ISA has stepped up their game to come up with some new standards and guidance. I know I have here reference to ISA 84, but there's also the ISA 62443, and they released some new information this year back in April-May timeframe that talks to identifying safety integrity areas. And the bow ties can be used to identify and highlight some of these critical pain points and you can sell that to your management to dig deeper and come together, like Dale was saying, with your subject matter experts in the security space and helping to improve the processes within, your operating environments. Next. So here's the bottom line. Focus from a PHA perspective. We look at the PHA looks for ways to look at the process and how it may deviate from the original intended design. It typically doesn't look at the adequacy of the design. So here we have an opportunity as ICS security professionals to help them in that area from a security perspective. It usually doesn't look at the root cause or security threats, attacks, or impacts to the ICS operation. You think about the revenues and the company reputation in the event that a cyber attack were to hit an oil and refinery plant. That would be pretty significant. So what we have here created this visual display. We wanted to do an analysis to tie together the PHA and some of the recent cyber attacks that we've seen that happened in the last couple years. These are real threats. On the outer layer and the inner, we have the PHA. This is typically what happens in a PHA analysis. It starts from the risk, understanding your risk, and the middle tier, they ask the questions of what impact is possible within your oil and gas refinery environment, or even in the power utility sector. What can go wrong? How likely is it to occur? These are some of the questions that the PHA is designed to ask or answer. And on the outer layer, the top part, staying focused on that, some of the big things, egress filtering. Do you really know what's leaving your network? This is critical. And the bow ties can help you answer those questions. And we'll get to an example of what a bow tie looks like in a minute. Access and privilege controls, the top right. This is all about understanding your risk, similarly to how they do a PHA analysis within the plans. On the bottom, we have foundation and risk assessment. You look at your historical experience. It's good to get a snapshot of the things that have happened in the past in order to determine the things that you need to work on for the future. Bottom right, knowledge and experience. And I looped in the improper input validation. There've been a lot of attacks lately here that have happened. You think about the phishing, ransomware, and also web obfuscation, side channel attacks. There's so many attacks that deal with this that help us to understand and assess, hey, how much do we trust the integrity of our data, right? And that ties into the PHA from an analytical methods perspective. We as security professionals, we can help the OT engineers with analyzing these types of things. And to the left bottom, memory and firmware exploits. This is the crown jewels right here. If an attacker gets access to your PLCs or RTUs, game over. So this is a great area where we as ICS security professionals can help our PHA and OT engineers in assessing what they actually have in their environment and how to defend against it. At the bottom, priorities, people, reliability, and safety. OT architecture, you always want to be looking at your architecture to help you understand what the pain points are. I would say at least twice a year, if not once a quarter. Does our existing OT architecture, is it really designed and operating the way that we want it to operate? And also routine ICS capability review. This is something that we don't typically see too often where companies are really digging deep and understanding what their capabilities are really bringing to the table. Are they within spec? Are they meeting the requirements that they were set up and designed to deliver when you make investments in these technologies? And the bow ties can help us identify all these things right here. So we get into our bow tie for OT. Here we have an example of a bow tie. On the leftmost part, the blue boxes, we have the attacks, and next to them in the white boxes with the gray bars on top, those are our defenses. In the middle is our point of analysis, which is the FCC unit. And to the right of that is basically our impacts, and the boxes to the left of that are our reductions. So this is the kind of analysis that we can use and do the homework and the hardcore research beforehand, before an incidents happen within our environment. So let's see, drill down. We chose to focus on malicious firmware and PLCs, and also false or manipulated data configuration. In terms of the firmware and the PLCs, that's a hot and heavy topic. I'm sure a lot of you are very familiar with the process that goes on and making sure that those things are locked down. From a defense standpoint, I know I have trust chaining here. That's really more so done upstream. But I meant to have in here like firmware integrity verification, validation of your checksums, and we're always trying to find ways to improve our network monitoring of the PLCs and embedded devices. Below that, false or manipulated data. You think about the Ukraine attacks and some of the other attacks that have happened that we've been reading about and still investigating. We want to make sure that the data on our HMIs and on our workstations on the OT side are true to form. They're actually showing us the data that is really happening within our network. Improper input validation, and there's some other things that you can put in here to really tell that story in terms of your threats. Here I have a visual on what I consider to be helpful from a bow tie ICS cybersecurity perspective. You start with your PHA analysis at the bottom, and you work with your hardcore ICS subject matter experts to make sure that there are no security issues that are not addressed in your HPA. There's real value in that, and I've actually seen where this has been helpful in the oil and gas space. I'm constantly getting calls from different people asking the questions, what are some things that we need to consider when we're looking at our OT environment? The middle tier, to the right, we have advanced hunting. I think it'd be a good idea to have people inside your OT environment working side by side with your OT folks to address the issues that they may incur. In the middle, incident response, this is the center and focal point. There are not very many people that really know and understand how to dig deep and respond to incidents that occur, both whether it be safety or reliability related or cybersecurity related. And intel, mapping the things that come out O days or whatever the threats may be, and tying that up to the bow ties. The bow ties is at the advanced level. It can help us to identify those things up front before something catastrophic happens within your environment. And then I wrap it up with the bow tie integration. On the left, we have what the bow tie is designed to do: reduce unauthorized changes to your data within your OT environment, and make your systems data, make sure that there's some integrity with that, and also always finding ways to make sure your ICS security controls are up to date, because the threat landscape, as many of the keynote speakers have said, is constantly changing. And on the right side, I haven't seen too many people talk about the supply chain. I know that the equipment within the OT environment it lasts for years and years and years, but there comes a point in time when a unit will fail. And in the case of our scenario, when we look at the FCC unit, it was destroyed. So was the ESP. So you have to get a new unit to come in. How good are you at assessing the integrity of your new systems when they come in and make sure that they're operating at the levels that they need to be operating at from a supply chain perspective? And so with that, I'll give it back to Harry.
Thank you, Will. All right, so now that we've gone through a scenario in the OT environment with the FCC unit, I'll be talking about bow tie in the IT space. So we're going to be looking at an analysis of running a web server in an IT environment. So this could be something on-prem or in the cloud. But for the sake of this presentation, we're going to look at a web application hosted in IIS for data visualization. And so a few characteristics about it are that we're assuming there's an application pool running with least privileges configured. The server is a member of an Active Directory domain.
There's the normal firewall rules to allow the web traffic over 443 and the HTTP traffic over 443, and regular updates are being managed by the IT department. And then a last thing to note that's probably the most important thing here is that the data source for this web visualization is tied into, eventually tied down to devices on the OT network. So with that in mind, we'll go ahead. So new is in quotes here because the bow tie analysis is nothing new to the realm of safety, but it's a bit novel to apply it to cybersecurity. And the point of analysis here is going to be the operation of a software module, and then the top event is going to be the compromise of that module. And so when we do each point of analysis, we want to look at our threats and defenses and our impacts within the context of the cyber kill chain. So we want to be thinking about our threats. How are people doing reconnaissance? How are they weaponizing tools? How are they delivering them? What our compromise actually looks like is the exploitation and the installation of the tools or the exploit that they're performing. And then on the impact reduction side, how are we avoiding this command and control and action on objectives that the miscreant is trying to establish? I will, however, note that while we'll be focusing on malicious actors and miscreants for this talk, this approach really focuses on reliability and resiliency overall. We're trying to avoid loss of control over these software modules, but that loss of control could occur because of an insider threat or because of misoperation rather than malicious intent. So as I said, with a bow tie methodology around a software component, we're looking at the compromise of that component as our top event, and the context surrounding that is not just the software module itself, but the environment it resides in. And so up here we have a simple example where we have our unauthenticated access as a threat to our system and defenses that can be in place to prevent that. We can have transport layer security to prevent snooping, and that some of the firewall restrictions that you can put in place can put an obstacle for attackers to exploit that. And unauthorized access to data is a potential impact of not having those defenses in place. And in those cases, you can have least privilege implemented at a point level if you're visualizing data, at display level to prevent access to the displays displaying the data, or if your app pool is set up with least privileges, that reduces the impact because it requires an attacker to escalate privilege more so than if you had it with a privileged account. Now, this example is a simple one-to-one correspondence here, but that's not true in general of bow tie. There could be 6 threats and 10 defenses, and one individual threat could result in all the impacts enumerated. So moving from the point of analysis to a level 2 on this bow tie, we enumerate the various threats to the system and the potential impacts. So a couple just to highlight. Initially, we talked about unauthenticated access, but we also need to be concerned about authenticated access. And if credentials are compromised upstream, or we don't even have a credential compromise, but we have an insider threat, then that's an entirely separate concern that we need to consider outside of the unauthenticated vector. And then another thing I wanted to highlight here is there's a tip of a hat here to the physical access to the server. You know, one of the immutable laws of security is that it's not secure if they can physically access the device. So there's still physical threats to the IT systems, and that's why we need to have the physical protections in place. But in terms of the other threats, this is a smaller market share of the threats compared to the OT space, where in our PHA there were a lot more physical factors that we had to look at in depth. So moving from the layer 2 to a layer 3 here, we start to flesh out our defenses. And so when we're generating these barriers to put in place, it's typically collaboration between the subject matter experts and the security team, and putting ourselves in the mindset of going through the cyber kill chain and thinking about what an attacker's trying to do and what opportunities we have to get in their way and make their lives difficult. Something that, a very easy conceptual way to think about the bow tie in the context of cybersecurity is on the left side, you're working on keeping the bad guys out. On the right side, you're looking at limiting the damage when they get in. And then establishing this point of analysis and reducing impact, you're trying to hunt for evil to see where problems could arise. Another thing that you'll note on this is that there's some color coding on the barriers. And in this case, we tried to highlight an important characteristic of these barriers, which is the effort to implement. So the barriers in blue, such as, we lost our presentation there. I'll just keep talking and hopefully it'll come up in a minute. The barriers in blue are the barriers that are in place automatically. And by automatically, I mean they're either part of the development process of the product or they're part of the architecture that it's installed in. So these are ones that an administrator doesn't have to take initiative to put in place. It's kind of in place automatically. The next tier up is in yellow, which is barriers that are in place by configuration. So this requires some effort from an administrator to put these protections in place and configure them for the network reality that they're defending. And there's the potential for things to be misconfigured, but it's a lower, it's not a barrier for end users. And then lastly, in red, probably the least reliable would be the ones that are in place by operation. And so that would be something, passwords are an example of this because you have to rely on your users to handle their credentials responsibly in terms of not writing them on sticky notes and not making really weak passwords if there isn't a complexity requirement built into the product. So what I'm trying to highlight here with this color coding is one of the three main things we talked about was giving a complex view of security beyond passwords and firewalls. If we're just looking at the network architecture diagram with the walls on fire, then we're only seeing what's in blue here. And there's whole swaths of territory uncovered, like the threat of if somebody gets administrative access to the operating system, what they can do to this particular module, or the DOS, the denial of service threat, if they have a channel that they can contact the server with. So right here, I was trying to highlight a couple attacks where there's either not a lot of there's either not a barrier or an insufficient barrier in place by default or by installation. And so, for example, with this web application, there's little to no defense against the denial of service threat without doing some extra configuration. The platform IIS has a lot of opportunities. For example, establishing HA through a cluster of ARR and NLB nodes, or by CPU throttling within the application pools. Now, when you look at those two options, one of them is probably going to require bringing a couple extra servers on your network, and the other one is a trivial, couple clicks, you can set it up. So bow tie analysis is great because you can drill down to say, okay, which ones do I not have barriers for, and then what's the activation energy required for these individual barriers, and some of them that are very quick you can identify as low-hanging fruit and improve your security. So as I talked about, there's these two barriers that I identified in this scenario I'm susceptible to. And there's some things upstream that have to happen in order for somebody to use these different attacks. For the authenticated access, they need to compromise a user account upstream. And for the overloading the server resources, they're probably going to need to compromise some external resources that can contact this server. If we're talking about a web server that's operating in a cloud endpoint that's exposed to the internet, well, that's pretty easy. But if it's something on your network that's behind some protection, then there's a little more effort required to achieve that this prerequisite. But let's focus on the stolen credentials here in a minute. So if they exploit one of those, attack vectors, there can be some bad results, obviously. If there's incomplete or tainted data being delivered to users, then or services downstream, that's going to result in unexpected behavior, either by software modules downstream or by people that are making decisions based on that data. And then there can be a loss of productivity or visibility if there's a denial of service happening, obviously. And so while we have diagnostics like performance counters and we have monitoring and backups to restore from, we really want to prevent these in the first place. So I talked about upstream. So there's a concept of chaining here. So let's say we have here a user account getting compromised and then the web server compromised downstream. So let's say there's mismanagement of credentials going on. We've heard in the news a lot of databases, whole user database dumps occurring, and then there's somebody who say their account for a social networking site has the same password as their login for another account that they're using. So it's something that can happen, and then the attacker can use those credentials to pivot to another resource, that resource being the web server where they get authenticated access, and then they use that access to gain unauthorized access to data. So this is just a way to visualize a specific attack path that someone can take from one stage to the next, and to look at it not in isolation, because it's easy to talk about this particular scenario, but it's looking at it within the context of all the other body of threats so that you don't overreact to one specific attack path and neglect others, leaving them wide open. So this is a level 3 of the user account compromise. I apologize for the eye chart. The slides should be shared afterwards. But one thing that we notice right away is that there's a common barrier for all of the different attacks that have at least been enumerated in this example, which is multi-factor authentication. So if someone is talking to their IT department about protections that they could put in place and how to prioritize them, they could look at this and say, you know, we're really getting a lot of bang for our buck by doing this particular mechanism over another. And so sticking with the example of the mismanagement of credentials, there's a lot of things that we can do to to defend against this. We can do training to tell our users not to reuse credentials, and good luck with that. But federation, for example, if we're using SSO and there's fewer passwords that they actually have to use, then we have a better chance of them not reusing them because they don't have 100, maybe they have 12 instead. But then we come into the idea of having a reputable password manager that they're using to store those as opposed to sticky notes or text files or anything else silly. And multi-factor authentication or encrypting the disk so it can't be stolen from the disk directly. In terms of reducing the ability for people to pivot once they have those credentials, there are protections that we can put in place to help with that. Moving along. Okay, so Will gave a great example of the OT environment and how we can look at the wide range of threats and both cyber and physical. Then we talked about IT and how Bowtie is not limited to safety and how it can really talk about cyber stuff. So now how do we bridge the gap between those? So here we have an example of a simple architecture for a data flow, taking data from devices on the OT network and giving it to the plant historian where it can be visualized. So we have a PLC, which could be a target of an attack in a scenario like Will talked about, and then we have a web server that we can look at with the bow tie that I talked about earlier. So these are put up here to show where the bow tie resides in the network, so that we start with the architecture view with the firewalls and the zones, and then we can drill into the actual defenses and analysis. Now note that this here is, we could have those individual sites piping up to an IT network, a corporate network where the data is getting aggregated and visualized. And this This diagram here is another course or another web server application. And we can use the same bow tie because we're looking at the same theoretical defenses, but our analysis of that bow tie is probably going to be a little bit different. In the OT space, we're going to be focusing more on prevention. We're probably going to be looking more at the barriers on the left side. In the IT space, we might be more concerned about disaster recovery, and we might be thinking about it from a mindset of a more hostile territory, so we're going to be looking more on the right side. So it's the same theoretical possibility, and you evaluate it within different network realities. So we can identify critical concern. On one side, our industrial control system, we can talk about the attacks coming from the outside world, and we want to chain from one to the other. So a couple attack paths that can occur through this network. There's a thick client attack path where we go from a client workstation to the historian, an interface node to the device, and then we see that there's 3 intermediate layers that an attack has to go through, and we call this like a thick client kill chain. Similar attack path, but different is we're using a thin client architecture. Notice there's an extra loop here where it has to go through the web server. And so the key difference here is that we have that extra layer in the middle, and we have all the defenses and impact reductions available at that layer. And so you might be saying, all right, well, what did I actually gain there? I didn't gain anything over the architecture diagram. And you'd be right. The power comes in when you can look at everything within the context of where it sits relative to other attacks. So here, we can use the bow ties to look at 2 parallel attack channels going on at the same time. And in this case, we could have malware being used to pivot to the web server where they're exploiting a vulnerable component to act as a client to overload the historian, causing services to be delayed or unresponsive. So we could have a DOS attack happening on one level, and then we could have stolen credentials being used to access the web server and send tainted data to the historian that then is being used for some other purpose. So you can easily imagine that we have a smoke screen here in a DOS attack and then something more subtle happening under the surface. And so basically we're trying to bring together the approaches from both IT and OT to help inform our defenses and give a better picture. And we really want to see people working together on this. So to address some of the challenges and opportunities that we have, these diagrams can take significant resources to put together in terms of time and getting subject matter experts to work on them. It's a large surface area to cover to analyze all these modules, and we're using a threat and impact enumeration where we group attacks together into categories with actionable barriers that we can put in place. But that's a subjective measure, so there could be standardization put in place there. But strengths and opportunities, which we think are big, are visualizing with OT, IT, and even the C-suite, expanding the use of an industry standard technique to be used not just with safety, but also security, and leveraging existing capabilities. By that we mean whatever your maturity level is with your implementation, you can use this approach. The bow tie reflects the state of the art and the theoretical possible, and then the job for an asset owner is to determine what they actually have in place and what they want to do next. And then lastly, a note about collaboration with asset owners and vendors. Like I said, there's a large surface area to cover, so taking a distributed and collaborative approach to this would make it much more feasible. If vendors were publishing, if there was a cooperation to have vendors publishing the theoretical bow tie, then that would reduce the job for the asset owners to just determining what actually exists on their environment and what they want to do next. So thank you. If there's any questions, we'll do our best to answer them. But thanks for coming out.
Do we have any questions for the speakers?
Where does forensics fit in the bow tie security cycle?
Forensics could be part of the reduction of impact, but it's more likely going to be feeding into improving the bow tie. So one approach to generating a bow tie is that you can look at historical attacks and barriers that would have been useful there, And you just, as you add more and more case studies, you get a larger superposition of defenses, and it starts to flesh out into an actual representation of your security posture. So yeah, I would say forensics is really in the creation of the bow tie mostly.
I just have a comment, especially for the digital forensics thing. The bow tie model isn't that for the attack side? You can choose where you want to put your money. Actually, you can go a proactive way, or you can do it a reactive way. You understand?
Mm-hmm.
So the digital forensics side is, I don't see. Yeah, you can put on the log methodologies as a proactive thing, and then you can use it as a kind of digital forensic thing, yeah, up to the bow tie model. I don't know. Do you understand what I mean?
I'm not sure what your question is.
No, not a question. It was only a comment.
Oh, okay, then I get it, yes.
Yeah, only a comment.
Thanks.
Any other questions? I have one last question for you. I guess, can you talk a little bit about challenges of applying this approach on in production already systems that maybe you don't necessarily have a background on, and maybe they're historical and they've been around for 10 years. But what sort of challenges have you seen when you try to apply this approach there?
Yeah, so I guess the challenge there, are you talking about an asset, are you talking about, well, I can address both. In the actual generation of the bow tie, it can be challenging to assess what's actually in place in order to highlight what you have already implemented. We're trying to do our part to help automate identification of defenses. So we produced a set of scripts, some audit tools that try to automatically identify what people using our software have in place for their defenses and juxtapose them against the best practices. And that's a project that we have on GitHub, the PySecurity audit tools. So there are things like that that can help with the identification phase. But as far as the generation of the bow ties, that is an effort that requires getting subject matter experts in the room and really doing some heads down analysis. And that's why it would be really great to have collaboration with asset owners. Imagine if Microsoft put out a bow tie for defending a SQL server, and OSIsoft put out one for the PyData archive, and fill in the blank vendor with their product. So it would really reduce that load that we're talking about.
Great, thanks. All right, so I guess we can look forward to seeing OSIsoft's bow tie models, right?
In fact, if you want to see a sneak peek, there on our PySquare blog, small plug, there are some posts that have some of these bow ties in place. They're early prototypes, but they still have been helpful to several people already. So on the PySquare is the pysquare.com.